The last thing we're going to look at in this section is how to graph a logarithmic function. Now, in order to do that, we're going to have to call back on our knowledge of what we know about inverses. So remember that if I have a function f of x, and I have its domain, which is going to be all the possible x's, and I have its range, which is going to be all the possible y's, then everything about that, when I do the inverse, is going to switch. The y's become whatever is in my domain, and the x's become whatever is in my range. If I have an original function with x's and y's, I just switch the x's and y's, and that is how I figure out the ordered pairs for the new graph. And so to graph a logarithm, it's kind of difficult to understand what values to plug in. So the easiest way to graph a logarithm is going to be to start with its exponential function. They're inverses of each other. So if I can figure out how to graph my exponential function, it's much easier to plug into b to the x. Then I just need a couple points and I can flip-flop those, and that's how I'm going to end up with my inverse. So if you look at when b is greater than 1, so this is an exponential growth function right here. And if I take my ordered pairs and I switch them, remember if I put in 0 for x, anything to the 0 power is 1, so I get the point 0, 1. The logarithm, which is the red function here, is going to reflect over that 45-degree line, y equals x. And we've talked about that in the last chapter. And so we end up with this red curve right here, and you notice the x and the y just switched. The same thing with exponential decay. Instead, it looks, it's going down, so when it reflects, we're going to have this shape right here. So just the red is what we're going to be looking at graphing, but we are going to use the exponential values to come up with the table. Now don't forget, the domain and range is always going to switch. So we said that for exponential functions, the domain was all real numbers. Well, for logarithms, the range is all real numbers. And for exponential functions, the domain was x's greater than 0. So now the range is going to be y's that are greater than 0. And since we had a horizontal asymptote at y equals 0, now it's going to become a vertical asymptote at x equals 0. Everything about it is going to switch. And we'll talk about this in a lot more detail in the next section. So let's go ahead and try to put some of this together and figure out how to graph these. So we want to give the equation of the asymptote, and we want to state the domain and range. So to start, and this is what I've got set up for you to do on your assignment tonight. To start, we're going to figure out what the exponential function is that would be the inverse. So if y is equal to the log base 3 of x, the inverse is going to be y is equal to 3 to the x. 3 is the base because that's the base of the log. And then because we want the exponents there, this is what we end up with. So just kind of a side note, when we do the inverse, remember we would switch the x and the y. So we'd get log base 3 of y. And then when we go to rewrite that in exponential form, this is what we end up with. So we want to start with that table. So this table here, I'll just do from -1 to +1. 3 to the -1 is 1/3, 3 to the 0 is 1, 3 to the 1 is 3. We are going to switch this now for the log function. So my new table is going to take 1/3, 1, and 3 for my x's now instead of my y's. They flip. And my y's are now going to be -1, 0, and 1. So let's take a look at what that looks like. 1/3 -1 would be about here. 1, 0 is going to be right here. And then 3, 1 is going to be right here. Our asymptote goes from being the x-axis to now it's the y-axis. So we'll go ahead and sketch that so that we know where we can't cross. And so our graph is going to look like this. Ta-da, that's the graph of the log function. Now, you didn't have to graph the exponential function, but it would end up being here, like this. And so you see, if we kind of imagine that reflection line here, that we have perfect inverses of each other. Our x's and y's are switched. You only need to graph the logarithm. And so then it asks for domain, range, and asymptote. The domain is restricted because I can't go past 0 on the x-axis. So the domain is x is greater than 0. The range is going to be all real numbers on this one. And then the equation of the asymptote, because it's a vertical line, it crosses the x-axis, so that is going to be x equals 0. And so those are all the things that we want. So let's go ahead and look at B. The exponential function that would be its inverse would be y equals 5 to the x power. So I want to make a table for 5 to the x, negative 1, 0, and 1. That's going to be 1/5, 1, and 5. Now we're going to take all of this and switch it around. Whoops, I still want this to be x and y. But I'm going to take all my y's and put them in the x column. 1/5, 1, and 5, and then negative 1, 0, and 1 here. So 1/5, negative 1 is going to be real close to the y-axis here. 1, 0, and this time it's 5, 1, so you see it got a little bit steeper. Looks like that. Make sure to sketch your asymptote. And so we would do domain and range. The domain is x greater than 0. The range is going to be all real numbers. And then the asymptote is the same for all of them right now, and that's going to be x equals 0. Go ahead and try C on your own. Put the video on pause, and you can come back here and check your answer after you have done that. Here is the graph that I get. I didn't sketch out the tables, but you're going to start with y equals 2 to the x. So you get the ordered pairs negative 1, 1/2, 0, 1, and 1, 2. So then you flip those all around, and that's how we get these graphs. So hopefully that works out okay for you, and I will see you back here next week.